From figure 6, I found an equation relating voltage to Celsius. Then with that equation, I made it a function of voltage, and so that you're outputting Celsius. Then, since Fahrenheit is 9/5 times Celsius plus 32, multiplied by 9/5, added 32, and divided by 100, so that the output is in Fahrenheit over 100, so that the output is within millivolts. Then, to receive this portion, I used a non-inverting op-amp configuration to solve for those resistors, and then I solved for how we would subtract the 0.6167 from this value we just calculated. To receive 0.167, I used a voltage divider equation to find what the resistors needed to be. I then used an op-amp voltage adder so the impedance of the existing circuit wouldn't be affected. It can be seen that our ambient temperature is equal to our multimeter readout within millivolts, 63 degrees Fahrenheit. First off, starting with our voltage supply, created a negative bus right here and a positive bus right here with our 2 9 volts. Then we have our voltage source for our temperature sensor, which is right here, 3 volts coming in from these 2 batteries, fed right here, negative fed to the ground. The ground obviously is connected to keep everything consistent. This voltage is fed over here, and then the ground obviously is fed to the ground. Resulting voltage is fed from this all the way over to pin number 3, the non-inverting input of op-amp number 1. And then we have the second pin connected to a 10K, which is connected to the ground, and a potentiometer, which is connected back to the output, which is pin 1, and that can be seen right here. And then we have right here a pin 1 connected all the way to pin number 12 with a 1K, as well as another 1K connected to the ground. So that can be seen right here, 1K back over, and then we have our second 1K back to the ground. Then we're going to go back over here. We see this 3 volt being fed in. Then we have our 10K being connected to the potentiometer right here. And at this node, you have the voltage feed coming out. You also have this potentiometer feeding back to ground, which can be seen right here. You have this feed going to pin number 10, which can be seen right here. And then you have 9 connected to 8. 9 is connected to 8 right here with that small little jumper. And then you also have another 1K, which can be seen right here, this 1K. And it's fed back, roundabout way, back to pin number 13. And at pin number 13, there is another 1K fed to pin 14. You have that happening right here. And that will feed to your multimeter, which has a feed connected to ground. That can be seen right here. We have pin number 13 connected to 14 with this 1K. And then we have the V out coming right here, fed to our multimeter. And then we have the ground, which can be seen right here. And that is connected also to our multimeter.
Your 32, perfect.